Today we're doing the August 2018 Regents exam, looking at some multiple choice here first. So the first one it says is 300 times 2 to the 4t, and it looks like we're going to have to just rewrite that into an equivalent form. So looking at the answer choices right off the bat, these two look kind of strange to me. The reason they look kind of strange is because you'll notice how the 300 doesn't have an exponent, and now all of a sudden it does. That's kind of bizarre to me. I mean, I could be wrong with this, but I feel like it's not going to be those two. Just right off the bat, those seem strange. And usually the first question is pretty straightforward. This one is not the easiest one, but it's not too bad. So think about 2 to the 4t. So 2 to the 4t is equal to 2 to the 4 all raised to the t. That's because of exponent rules. Power to a power means to multiply those two, and usually we go from this one to that one, right to left here. But in this case, we're starting with this one, and actually it helps to go that way. We just have to know that 2 to the 4th is 16, which, look at my calculator here, I already have it typed in. 2 to the 4th power is in fact 16. So this is equal to 16 to the t. So 2 to the 4th to the t is equal to 16 to the t. So we can rewrite that as 300 times just 16 to the t. And that, you'll see, is choice 2. That's why that's the answer. For the next one here, we're looking at a linear relationship. First thing that jumps out right there is that word linear. That's why I saw that. So we're looking to see which one is the linear model of exercise time and heart rate. And it says beats per minute, yada, yada, yada. I don't really need that much information. All it's really asking is which one is linear. Okay, so that's all we need to figure out. Which one has a constant rate. At a quick glance here, I'll see these are all the same, which means you don't have to even check those. Just skip on past those. Just look to see which of these are increasing or decreasing at a constant rate every time. So this is plus 5, plus 5, plus 5, plus 5. Boom, there's the answer, just like that. That's a nice question to get. This one's plus 7, plus 5, plus 5, plus 4, so that's clearly not going to work. This one's plus 3, plus 1, etc., plus 7, plus 2, that's not going to work. Plus 8, plus 13, boom. You can just tell right away, you only need one example of it not working, and the whole thing's not linear, whereas this one, every single time is plus 5, so it has to be the linear example. We would love to have that question as many times as possible on this test. That would be great. So that answer is choice 1. Moving on here to number 3. So number 3 is looking for us to factor. You can tell because it says the word factor, duh, and because you can see all the answer choices are all in factored form. So if you're not sure what the question's asking, just look at what the answers are, and you can kind of use that to work backwards if needed. So for this one, m squared minus 12m minus 64. So we're multiplying these where the leading coefficient here is just 1, meaning you don't even see it, which is why it's just a 1. You want to think about what multiplies to our c. So what multiplies to this over here, and what adds to this. So we want numbers that multiply to negative 64 and add to negative 12. We want two numbers that do both. So what numbers multiply to 64? Let's think about that first. So 1 and 64. Keep in mind, though, 1 should be negative. Okay, so when you're doing this, you can make 1 negative, either one. 2 and 32. And right off the bat, those don't seem right because they've got to be 12 apart. If they add to negative and they multiply to a negative, that means that one of them is negative. So looking to see how far apart they are from each other. The next one will be 4 with 16. And that looks good because 12, 4, and 16, that seems to fit because 16 and 4 are 12 apart. So if I want to add to a negative, I've got to make the 16 the negative one. So there we have it. It'll be m minus 16, m plus 4, because those multiply to negative 64 and add to negative 12. And then from there, that's it. That's all we have to do. There's our answer, choice 3. And we move on to the next question. For this one here, number 4, this is an equation that we're solving. It's a simple linear equation. And right off the bat, I see some fractional answers. So I'm wondering, I wonder if this is going to be a fractional response we're going to get here. But the other two are not, so we don't really know. So you could use, there's that tool on your calculator too, that nsolve. And that tool, you could just type this whole thing in and get the answer. This is multiple choice. I know it feels like cheating, but hey, if you're allowed to use it, you're allowed to use it. So if we go to algebra, numerical solve here, we can literally just type that whole thing in. I will show you the other way as well. I think I need a time sign here. Let's make sure I have that 1 minus 4x. I'm going to arrow over. I'm going to put the equals 3x plus 8. And you want to tell NSolve what you're solving for. We're solving for x, so comma x. And there we have it. The answer is 2. Wow, that was great. Now, of course, being a math teacher, I want to solve this a different way. I want to show my work. So multiply the negative 2 in, you would get 2 plus 8x. I'm sorry, negative 2 plus 8x because of the 1 there, equals 3x plus 8. Moving the variables over, we get 5x minus 2 plus equals 8. Nice little two-step from there, and we are good to go. X equals 2. There we have it. So that's why that problem 4 has an answer of 2. Moving on to number 5. So for this one, let's see, graph of a function wants f of negative 3. So that means the input is negative 3. That is always an x value. So we're looking for a y value that is equal to the function at this x value. So at negative 3. So we have to look at the graph. I'm going to zoom in here. Here's negative 1. Here's negative 2. Here's negative 3. The graph is right here. This is f of negative 3, which is at 1, 2, 3, 4, 5, 6. So f of negative 3 is just 6. And that's all there is to it. Again, we would love to have questions like that. That's a great question. Okay, here we go. If the function has this as its domain, what's its range? So range is all the outputs, and domain is all the inputs. So think of a function like a machine. You're putting these into it, in for x, and then coming out will be our outputs, will be our y values. So all we have to do is put these numbers in. So what is f of 0? What is f of 1, 4, and 9? So 0 squared is 0, 1 squared is 1, 4 squared is 16, 9 squared is 81, and that's it. We're not square rooting here, which is why there's no negatives or anything. Like it's trying to trick you and think, there's some negatives involved there, but no, it just wants the outputs. It just wants the y values, which is just the 0, 1, 16, 81, done. Choice 2. For number 7, here's where it doesn't ask you to factor, but looking at the answered choices here, you can tell it's asking you to factor because they're all in factored form. They're all two things being multiplied, which is factored form. So 4x squared minus 25. When you're factoring expressions look like this, you can tell that it's not going to be like the last one we factored because there's not 3 pieces. This is what we call a binomial. There's only 2 pieces. So binomials can be factored one of 2 different ways. You can use a GCF, or you can use difference of perfect squares. Always look for a GCF first because it makes things a little bit simpler, but I don't see any GCF, so that's not going to work. So we're thinking about squares here. So difference of perfect squares like a squared minus b squared always factors into a plus b and a minus b. So basically the square root of each of them goes here and here, here and here, 1 plus and 1 minus. So for 4x squared, the square root of 4x squared, the positive square root would be 2x. So 2x is going to go here, and it's going to go here. And the square root of 25 is 5. So a 5 and a 5 here. And the only trick is to make sure one is positive and one is negative. So 2x plus 5, 2x minus 5 is our answer. Choice 3. There it is. Okay, number 8 is transformations. So you can see here that g of x is a transformed version of f of x. So there's a minus 2 and a plus 3. These are great Regents questions. I love to ask questions like these. The plus 3 is the one that makes a lot of sense. That goes up 3 on the outside. So we look for one that has up 3 on it, and only that one does, and we're done. That's all there is to it. The reason that this one's kind of tricky, the inside one, is it's kind of backwards from what you would expect. So a minus 2 inside, you might think, oh, that goes left 2. No, actually, minus inside with where x is goes to the right 2. If you're ever not sure, you just kind of got to graph these. If you go over to your graph, you can type these in really quick and do x squared, look at the parent function, and then type in a new one. If you hit tab here, parentheses, x minus 2, close the parentheses, squared, plus 3, you'll see exactly what transformations happened. It went to the right 2, and it went up 3, as you can tell in that picture right over here. Number 9 here, word problem. Looks like it wants a system for us to make a system for this. So 30 coins total and money. So we're talking about two different things here. We're talking about how many coins and how much money. Those are going to be our two equations. So it wants you to use two variables, so dimes and quarters. So the dimes plus the quarters are 30 total. So it has to be that one. So it can't be that and it can't be that. Because this is how many of each. Whereas the money one, we should say the amount of money for each dime and the amount of money for each quarter is equal to the money. Money, money, money all together. And that's why it's got to be choice 2, because it's got the 10 cents per dime. This one says 25 cents per dime, and that's totally wrong. So it's got to be choice 2 for number 9. On to number 10, we've got some inequalities here. You'll notice that there's 3 of them, which is kind of complicated, but that's okay. It's nice because maybe we don't even need the more complicated one. Maybe we can just look at the simple ones to get the answer just because of, process of elimination here. I'm just kind of skipping a part to the part I want to read here. A minimum of 10 rides. So a minimum of 10 rides means that 10 is the least she wants to go on. So 10 or more. So if R is the rides, like it says, then R has to be at least 10. It can be equal to it, or it can be bigger than it. So all of a sudden, we're down to that one's gone, that one's gone. It's got to be 2 or it's got to be 3, which is great. And you'll notice here that G is different in both of them. So if we just check G, we're done. So G is the number of games. So the games are at least 12 games here. So at least 12 games would be G is greater than or equal to 12, because at least can be included. That's why it's choice 2. For number 3, we're looking at some functions here and it wants us to kind of just compare them. So which of these is true? We're looking at the y-intercepts, which is pretty easy to compare here. This y-intercept is 1. This y-intercept is the y value when x is 0, which is -1. So -1 versus 1, that one's pretty easy to see. The y-intercept for g would be g of 0. So 3 to the 0 plus 2 is 1 plus 2, which is 3. So if we're comparing these 3 numbers, we're trying to see which of these is correct. So this is going to be the y-intercept for g is definitely bigger than that one. And it's also bigger than that one. So there we go. Choice 4. The y-intercept for g of x is greater than the y-intercept for both f of x and h of x. Not much else to do with that. And then if we go to the next page here, number 12. Having trouble scrolling here. Here we go. So number 12, this is called dimensional analysis. This is one of those things we don't use that often, but it does come up, here and there as kind of one question on the Regents. So it's a nice way to convert between units. So you'll see here, she's using what we call conversion ratios, or basically multiplying by 1. So she's starting off with 4 quarts in 1 gallon. So this is equal to 1. There are 4 quarts in 1 gallon. And I'm trying to figure out, let's see, what's incorrect about her conversion. So we're trying to see what she might have done wrong. So what I would look at is the units. Looking at these units here to see what went wrong, what part of this is incorrect. So you want the units on the top to match with one on the bottom that's going to cancel. So quarts and quarts, top and bottom, cancel. So that's set up correctly. Pints and pints, top and bottom, would cancel. Cups and cups, that's the problem. Okay, so this one should be flipped. And you'll see why in the next part too, because you'll see here tablespoons and tablespoons. That should be up top. It should be 4 tablespoons over 1/4 of a cup. That way the cups on the bottom with the cups on the top would cancel, and tablespoons would cancel. So this is the part that is wrong, and that's why that's the choice that we want for this problem.